Geometry, Unit 9, Section 5, solving problems using sine and cosine. That should mean either. For each given right triangle, use the given acute angle and the given side length to find the two unknown side lengths to the nearest tenth. So we're solving for x. We also want to find that. We're not going to do it for all of these, but let's just solve for x on this first question here. So at this point, we've learned the sine, cosine, and tangent ratios, and it's been mostly, given all the sides, what's sine of this angle, and you're just listing a ratio. But how are they really helpful here? And that's really what we're going to see here and in the next couple of videos. And in class, we're going to see a lot of word problems, a lot of modeling questions, a ramp of this length has this type of angle, how high is it above the ground, stuff like that. And so this is where trig really has its most value in is solving real world applications like this. But we're not going to do word problems. We're just going to get through the structure of the equations here, and then we'll see the word problems later on. So what we need to do to solve for x here, see what we have. We have an angle of 47. We have a hypotenuse that's a length of 3, and I want to find the side length of x. Now, one thing we need to note is, what could I call this side? Is it the opposite side? Is it the adjacent side? Is it the hypotenuse? Now, it's obviously not the hypotenuse. There's only one of those. So is it opposite or adjacent? Well, it depends on what angle I'm working with. If I were working with this angle, it would be opposite. If I'm working with the angle I have, 47, it's adjacent. And so I'm going to use adjacent for this side's title because that's what it is in perspective to the angle that I'm going to use for the problem. Could I figure this angle out? Absolutely. It's 43 degrees. And then I could call it opposite. But whatever angle they tend to give you, that's usually the one we use. It doesn't have to be. You can figure out the other. But if you use the angle they give you, then what is it in relation to that? Obviously, hypotenuse is hypotenuse. But right now, this side labeled x is adjacent to the angle we have, 47. So step one is figure out, what are your sides' titles? Step two is determine what function are you using. Are we working with sine? Are we working with cosine? Are we working with tangent? And because we have adjacent and hypotenuse, that's the cosine function. So we've determined that the function is cosine. Then every trig equation is set up exactly the same way. I'm going to put this up here. This is important. It goes function, angle equals ratio. Function, angle equals ratio. Function is sine, cosine, tangent. Angle, well, if we have the angle like 47 degrees, it's 47. If not, maybe that's theta or something like that. It equals ratio, that's your this over that, 5 over 7, x over, whatever the problem's talking about. So function angle equals ratio. We got to determine the function. We figured out cosine based on adjacent and hypotenuse. The angle is 47, and the ratio for cosine is adjacent over hypotenuse. So what we have for adjacent and hypotenuse are x and 3. So cosine 47 equals x over 3. We knew it was cosine because of the sides from this angle's perspective. 47 was given to us, and it's x over 3 because that's what cosine is, adjacent over hypotenuse. Then to solve this for x, we cross multiply. We can put this over 1. X times 1 is x. 3 times cos 47, so 3 times cos 47, and this is where our calculator is going to come in. We're going to round to the nearest tenth. And I'm going to type that in exactly as I see it. I'm sorry, I thought my calculator was open here. Now, one thing we have to be prepared for is we need to make sure our calculator is on the right setting. Anytime your calculator is reset, or if you borrow a friend's calculator or anything like that, you want to make sure you check the mode. And by default, it's on this word radian, which is something you're going to learn about later. We're working with 47 degrees, so we want to make sure we're on the mode degree. So make sure you're on the degree mode, and then you could type in 3 times cosine 47. 3 cos 47, and we could round this to the nearest tenth. It would be 2.0. So it's just 2. Or 2.0, technically rounded to the nearest tenth. And that's my answer for that side. How about this? Let's find this one over here. So we got 41 degrees. From that angle's perspective, x is opposite. The 4 is adjacent to it. The hypotenuse we don't have. So I'm working with an opposite x, an adjacent number. That must be the opposite over adjacent tangent function. So it's tangent 41. It's not just tangent equals, it's tangent 41 equals. It's always function angle. Functions tangent angles 41, that equals tangents opposite over adjacent, so that's x over 4. Cross multiply here, I'm going to get, again, x times 1 is just x, and 4 times tangent 41. X is approximately 4 times tangent 21. 4 times tangent 41 is 3.47, so we'll round that to 3.5. And your answer should kind of make sense too. Like this one, I got this was 2, my hypotenuse was 3. If my hypotenuse is 3, I know this is going to be less than 3. And, you know, these are drawn pretty much to scale for the most part, so you should be able to kind of tell what looks right, what doesn't. This looks like about 3.5. Actually, this looks a little bit longer. But this angle over here, if this is 41, this angle would have to be 49. And what's opposite 49 is going to be a little bit bigger than what's opposite 41. So that one's not drawn to scale, but a lot of times it is. All right, a couple more. Let's do this one from 61's perspective. This is opposite. This is the hypotenuse. And so that is the sine function that uses those. Sine 61 is x over 28. A little cross multiplication. I get 28 times sine 61. 28 sine 61. You don't really have to hit the times button before it, because when things are up against each other, it means multiplication. 24.5. Again, does that make sense? Well, it's less than the hypotenuse, so that's good. 24.5. Okay, how about this one? From 40, this angle's perspective, well, this is the hypotenuse no matter what, and this is adjacent to that. So that would be the cosine function. Cosine 40 equals adjacent over hypotenuse 9 over x. All right, so the three problems above this, x was the numerator. X over 3, x over 4, x over 28. This is the first time we're seeing x in the denominator. That's still okay. We still proceed the same way. We cross multiply. Except when we cross multiply this time, it's not x times 1 like it was in the other ones. It's x times cos 40. And 9 times 1. So I'm not quite ready yet. Still got to keep solving for x. And now I'm going to have to end up dividing by cosine 40 to get x alone. So 9 divided by cosine 40. I mean, the shortcut is whenever x is on top, it's going to be the side times function angle. Whenever x is on the bottom, it's going to be the side divided by the function and angle. But so if x is in the denominator, you do need to cross multiply, but then you'll have to divide by your function angle in the end. So let me clear some space here. So 9 divided by cosine 40. So sometimes we need to do multiplication, sometimes we need to do division. 11.7 is our answer. So x is approximately 11.7. That's our hypotenuse, so it's got to be longer than 9. All right, one more example, and this one's very different. This one, I'm giving you a triangle that is not a right triangle, and I want to find x here. There are different ways to do this. There's something called the law of sines and law of cosines that you're not going to learn this year. You actually probably won't learn it until pre-calculus. So we have a different way of solving this. Sine, cosine, and tangent, we've been saying for a while now, are restricted to right triangles. This is not a right triangle. So how could I possibly do that? Well, what we could do is we could turn it into two right triangles. I could take, and it's best to take your largest angle and draw an altitude, because then I know this is 90 degrees, and I can figure out this angle. This does not bisect 99. It definitely does not. I need to figure out what these angles are separately based on the fact that this is 39 degrees. So this one would be 51 degrees because they got to add to 90. And this is 90 degrees. This is, well, I could subtract 99 minus 51, or I could think about these adding to 90. This would have to be 48. Okay, then I'm working with two triangles at once. I can't find this whole side at the same time, but I could find this piece just from here to here working on this triangle, and then I could find this piece on the right triangle. And together I could add them together to be my missing piece. So, left triangle, I'm looking for side A. Now I have both angles, so it doesn't matter which one I do. If I want to use the 39, that would be cosine A, cosine 39, sorry, because A is adjacent to that, and the hypotenuse is 4.04. And so I can get A this way. Or I could do 51 and do sine A. Sine 51 is A over that. That would also work. And then on this side, I'll find B over here. Again, I could do cosine 42. Cosine 42 would equal B over 3.85. And so I could find B this way. And in the end, I'm going to add them together. So let me do this. We'll round to the nearest tenths. So for this one over here, it's going to be 4.04 times cosine 39. And on this side, it's 3.85 times cosine 42. And that's 2.86. So that's going to be 3.1 and 2.9. So this is 3.1, 2.9, right? Get that order right? Yep. 3.1, 2.9 for a total sum of 4. So x equals 4. Add the two pieces up to get the whole thing. So that's the hardest place this could be, that if it's not a right triangle, you can draw in an altitude making a right triangle, and then making two right triangles, and then finding pieces piece by piece using your trig ratio. So set up function angle equals ratio. You definitely need your calculator here, and don't make mistakes on rounding. It's a silly reason to lose points. See ya.